Welcome to Rayesh Shikshan Sanstha's Western Region English Medium YouTube channel. Today we are going to learn subject Science and Technology Part 1 Standard 9 Lesson name Work and Energy. Video number 6. Potential energy. The energy stored in an object because of its specific state or position is called that its potential energy. Here, some examples are given in the picture. An arrow is released from a stretched bow. Water kept at a height flows downward. A compressed spring is released. Which word describes the state of the object in the above example? That is energy. And where did the energy required to cause the motion of object come from? Yes, it is stored energy. So, the energy stored in an object because of its specific state or position is called its potential energy. Expression for potential energy. To carry an object of mass m to a height h above the earth's surface, a force equal to mg, that is mass, into acceleration due to gravity has to be used against the direction of the gravitational force. The amount of work done can be calculated as follows. That is work, as we know that work is equal to force into displacement. So work is equal to force. What is force? Mass into acceleration, gravity, and displacement, that is height, h. So work is equal to mgh, the amount of potential energy stored in the object because of its displacement, that is potential energy, is equal to mgh. W is equal to potential energy by putting the value of W in above formula. Transformation of energy. We learned about various types of energies. Energy can be transformed from one type to another. For example, exploding firecrackers convert the chemical energy stored into them into light, sound, and heat energy. Here in the picture, we can see some energies. Example, electrical energy can convert it into mechanical energy. So given example, electric fan. Then electrical energy can convert it into light energy. Example, solar cell or photoelectric cell. Electrical energy can convert it into chemical energy. So that primary cell and secondary cell may be examples of there. Then electrical energy converted into sound energy. That for example loudspeaker. And then electrical energy can convert it into heat energy, for example heater. So here some energies are there, and energy can be transformed from one type to another. For example, the exploding firecrackers convert the chemical energy stored in them into light, sound, and heat energy. Law of conservation of energy. Energy can neither be created nor destroyed. It can be converted from one form into another. Thus, the total amount of energy in the universe remains constant. Here, we can do one activity. Tie the two pendulums to this horizontal thread in such a way that they will not hit each other while swinging. And now, swing one of the pendulum and observe. What do you see? You will see that as the speed of oscillation of the pendulum slowly decreases, the second pendulum, which was initially stationary, begins to swing. Thus, one pendulum transfers its energy to the other. Free fall. If we release an object from a height, it gets pulled towards the earth because of the gravitational force. An object falling solely under the influence of gravitational force is said to be in free fall or to be falling freely. Then, as shown in the figure, the point A is at a height h from the ground, and let the point B at a distance x. Let be the point C be on the ground. Let us calculate the energies of the object at point A, B, and C respectively. So for first when the object is stationary at point A, its initial velocity, that is u, is equal to 0. So what the formula we have in previous lesson, in previous part of the lesson, that kinetic energy is equal to 1 half mv square. So here kinetic energy for the initial velocity, that is 1 half mu square. Then as the u is equal to 0, so putting the value of u here, kinetic energy is equal to 0. And what is the we know about the formula of potential energy is equal to mgh. So total energy, kinetic energy plus potential energy. Then putting the value, kinetic energy 0 and potential energy mgh. So total energy is equal to mgh. Here we get equation number 1. Second, let velocity of the object vb when it reaches point B having fallen through a distance x. Here u is equal to 0, s displacement is equal to x, and a acceleration due to gravity, that is g. So we know the Newton's third equation of motion. V square is equal to u square plus twice as. So here we have to calculate at the point B. So Vb square is equal to initial velocity 0 plus twice gx. So Vb square is equal to 2gx. And we know the formula. Kinetic energy 1 half mv square, that is we taken here Vb square. So 1 half m Vb, what the value of Vb, put here in the bracket 2gx. Kinetic energy is equal to mgx. Height of the object at point B is equal to h minus x. So potential energy is equal to mg, but in the bracket h minus x. So potential energy mgh minus mgx, and total energy we know that kinetic energy plus potential energy. So mgx plus mgh minus mgx. So mgx cancel here, remaining total energy mgh. Here we get equation number 2. Let the velocity of the object vc when it reaches the ground near point C. Here again initial velocity u is equal to 0, s the height, displacement is the h, a is equal to g, acceleration due to gravity. So here Newton's second equation of motion v square, again third equation of motion, that is v square is equal to u square plus 2as. Vc square is equal to 0. As the initial velocity u is equal to 0, we have the value, and 2ghas we have the value gh. Kinetic energy 1 half mvc square. So kinetic energy 1 half mg 2gh, and kinetic energy is equal to mgh. We get the value. The height of the object from the ground at point C is the h is equal to 0. P potential energy is equal to mgh, that is 0. So total energy becomes kinetic energy plus potential energy. Then total energy is equal to mgh. Equation number 3. From the equations 1, 2, 3, we see that the total energy of the object is the same at the point A, B and C respectively. Power. The fast or slow rate of the work done is expressed in terms of the power. Power is the rate at which work is done. If W is equal to amount of work done in time T, then power is equal to work upon time. So power is equal to work upon time. Unit of work is joule. So unit of power is joule per second. This is called watt. In the industrial sector, the unit used to measure power is called as horsepower. Do understand the concept and revise at home. Thank you.